So it's full screen on my screen here. Right. What's up? Yeah, but it doesn't go full screen here, but it does it on my screen. Is that fine? Okay. Anyways, hello everyone. Thanks for showing up. My name is Piotr Marszalik. So AVs flagging our payloads and dying shells, a classic problem. So in this talk, I'll be going over my take on this and the approach we've been taking on some of our pen tests. The overall theme, as you'll see in a bit, will be leveraging PowerShell as well as a number of built-in Windows tools to our advantage to address these two issues. And for those who know what a shell party is, it means having a lot of successfully executed payloads, a lot of incoming shells, something we typically see during social engineering and phishing exercises. So hopefully after this talk I can have a couple of you on. So before diving in, some background information about myself. I'm a senior consultant and a penetration tester at Crow Horwath. I work on all types of pen tests, including internal, external, web app, social engineering, some physical. I'm a huge Metasploit and Ruby fan. I've been leveraging that too fairly heavily for most of my recent development work I've touched. Okay. So as mentioned, the issue we have dead shells in AV, something every pen tester runs into. So the overall approach, rather than uploading any third-party binaries onto our compromised system, what we'll be focusing on here is leveraging what's already on there, so Windows and primarily PowerShell, to address those two issues. So what I'll do, I'll start by going over how I've been handling dead shells. After that, I'll go into some things with PowerShell that you might consider using on your own pen tests. Okay. So to combat dead shells, the most obvious solution is to establish some sort of persistency or backdoor on our compromised system. There's a lot of different ways out there to establish persistency, but that is not what this talk is about. What we're looking for here is something quick and clean that while we're on a week or however long our pen engagement is, we can demonstrate an impact by doing appropriate amount of post-exploitation. So looking at a couple techniques out there already available for us, I mapped it down to the following four considerations. So the first one, we have profile startup scripts. Those are initiated when the user reboots or logs into our system. Since during pen tests, a lot of our users don't typically reboot or relog in, that's not really good for us. It means no reboot, no relogin, means no shell. The second one we have is payload as a service. Here we would need some sort of local administrative access in a system, which is not always the case. Also, if I was an admin and I see some atypical activity on the system, the first place I'll look for is tasks and services, so it's not always the best. The next one we have scheduled tasks on event. So here what we would do is schedule a task to call our payload on specific events or after a certain amount of minutes or hours maybe. Most of the other methods, we still have to upload our executable, which at some point might get flagged by AV. And also, if we just specify to execute every couple of minutes, we'll just be swamped with shells. So it's not very flexible. And next one, we have rootkits. This most likely have to be more targeted attack, and again, would also require us to have elevated privileges onto that system. So again, something probably we wouldn't want to use on a pen test. So requirements. So in an ideal world, something that my persistency method would have is where I map here. So starting with something light and easy to clean up. The next one, I don't want to use any, well, first of all, AV. I do want to get flagged by AV. So let's say I drop an executable. Even though it might not be getting flagged now, at some point in the future it gets flagged. It's not really something I'd want. Also, no sketchy file names and service names. This is common with Metasploit, where the file and service names get automatically generated, so a random string. So when I have an administrator and he sees it, I don't want him to freak out, like, what is this? The next one is it works with any level of access. So we have domain users versus domain users that might have local administrative access. And then the last one, we have something that's easy to manage. So my persistency method, let's say I want to set it up on 20 different systems and I don't want to babysit the handler. You get the picture. So from there, the solution I came up with is a web-based backdoor. So starting with a high-level concept of the way it works is, it starts with a scheduled task that any user can set up, which then the scheduled task will call Bit's admin job, which also you don't need any elevated privileges to set up. And for those not familiar with what Bit's admin is, it's pretty much a command line tool. You can use it to download and download and upload jobs, similar to what curl or webget are in Linux, and it's built into all Vista systems and up. So from there, we have our Bits admin, which will then go ahead and download a web page that we have on our web server. And again, the web page is a simple text file, nothing fancy. But it's also the most critical step, will be the text file here, which in the end is going to be our payload. So the Bits admin will download it, convert it into a batch file, and run it. So at that point, well, the main thing too is if the payload page does not exist, it's going to keep hitting home. But if it sees something that we put something on there, it's going to download it, turn the batch file, and run it. And this whole process will get repeated depending on our scheduled task configuration. So what does this accomplish? Well, first of all, at this point, we have a remote control over that system's command prompt, so which any pen tester will know it's kind of huge. Although at this point in time, the session itself is not interactive. We're just throwing the command on our web server and gets executed. But next one is the web traffic itself. We're not doing anything malicious, so the Bits admin will just hit our system and every couple of minutes. So very stealthy from like IDS perspective. And also the last one is already mentioned. Anything that we're doing is AV safe. The payload itself is not touching disk at any point. It's residing on our system. So again, nothing really to flag by AV. So the next one here, we have more detailed view of the backdoor and how it works. So here we have a post-exploit scenario where we already compromised the system. So here's our attacker and our attacker's web server. So starting with the two things that we'll do is, after we already have a shell, is we'll generate a small VBS script and we'll schedule a task to run that VBS script every number of minutes. And here we have our user, and from that point, that's all we do. So at that point, we establish persistency in our backdoor. Now, depending on our scheduled task configuration, a couple things will happen. So this third step you guys see here is something that will get repeated. So our task schedule will then call the VBS, which the VBS will use Bits admin to download our text file if it's not empty, and convert to a batch file and run it. Okay. Since I do like leveraging Metasploit for shell management, what I did is I wrote a module that pretty much automates this whole setup here. So starting with, there's a couple things you have to set up to configure this. The first thing, we have a web server, which will be just IP address or a domain name of our hosting server. So this could be anywhere. This does not necessarily mean we have to put in our backtrack box or Metasploit session. This could be any web server that we have access to. The next one, we have target URI, just a payload page, also could be anywhere. Scheduled task, like the name is saying here, is just name of a scheduled task that we're going to set up. VBS will be the path to the backdoor file, so we can place this actually anywhere in the system as long as the user has read and write access over it. We can copy it over. And the last one is a frequency, which how long do we typically will want to have our scheduled task try and hit our home server. Okay, so here's a screenshot of, hopefully you guys could see that. The screenshot from Metasploit itself and some of the default options that I would typically use. So frequency, I'll typically keep it to 5 minutes. Since traffic is a minimal and now in a shell, that sounds reasonable. The next one is the scheduled task, which is our name. Typically, I'll set up something like, oh, why is it loud? No one's saying anything. Next one we have is scheduled task, which is just the name of our scheduled task. I'll typically will put something like Windows update, maybe Flash update, something that we might see out there and doesn't draw a red flag if you see it. The next one we have target URI. What I like to do is to keep the management of my shells organized. What I'll do is I'll the user directories, I'll pull those from the environment variables from that compromised system. So typically I'll do an IP or host name of my IIS server, Apache server. Then I'll do the user's domain, the computer, and then the host name. That way I can just keep it organized if I have a lot of shells. The next one is the VBS. Typically I like to use app data just because I know every user will have full read and write access over that folder. And the last one is just our web server, which, yeah, self-explanatory, an IP address or a domain name. Okay, now when you run it, so here's a screenshot from Metasploit Console itself, also from a victim's machine. So from Metasploit Console, we see here two things happening. We have our VBS getting scheduled. Also, we see the scheduled job getting set up to call home every 5 minutes. And then at this point here, we have the IP address of our system. So in this example, I'm just using a private IP address. And also, these are the environment variables that get pulled from my system. On the victim will see two things. The first one being is a scheduled task, and also the small VBS file, which pretty much all it does is starts bits admin. So again, nothing malicious there. Okay, for the management, the best way to find if the hosts are still alive is just to look at the logs. So you can pull Apache IIS logs, and here we have an example. Every 5 minutes, we have our system just hitting home, trying to call home, see if that text file is out there. And from there, we can pretty much conclude which hosts are persistent, and from here we can determine, okay, do I want to attack it, or do I want to just hang on to it for now? And as a quick proof of concept, if I were to create those folders in my Apache, and then quick text file with just calc.exe. So next time the system calls home, pretty much opens up calculator. Okay. And the last one is cleanup. So if you have an interactive interpreter shell, you can just set the kill option to true and run it. Also, as an alternative, you can also paste those following two lines on your server, and next time the system will call home, it's going to execute and pretty much delete the persistency that you have on there. So at this point, we don't have an interactive session at our system, simple commands and batch file, but that's great and all, but what if we want an interactive Metasploit session? So that brings me to my next section, which we'll talk about Powershell. So Powershell shellcode injection is nothing new. Powersploit and also Dave's execution policies and payloads and set, those have been fairly common. What I did is I wrote PS1 in code, but main reason for that was when I wrote this, originally there was an easy way to generate those payloads. If you want to create something quick, you have to pull up Windows PowerShell and generate the base 64. Also, at the point when I wrote this too, you couldn't really specify the different formats. So as of now, the couple formats that it supports is we have raw and CMD, which are pretty much the same thing, except the raw doesn't have any of the PowerShell options. It's just a raw base 64. Then we have VBA, so something you can use in Office. So you have Excel, you have Microsoft Word. You can just paste that generated output into your macros. Someone runs the macros, pretty much spawns a new PowerShell instance, and you get a shell. Or that's something you would use with what is called Tomcat systems, and also the exe. What this will do is pretty much it will just spawn PowerShell and execute that code, but it just calls a system command. So tying the PS1 encode with our backdoor web, pretty much what would happen in that situation is we would generate a CMD and we would paste that onto our payload page at any given time that we want to get a shell. The next time the system phones home, it looks for instructions to see PowerShell, executes it, and since it is PowerShell, never touching disk, again, something that will not get flagged by AV. Also, for architecture, there's been a lot of, especially for reverse HTTPS, typically what would happen if you have to specify an architecture. So the way I bypass that is I just have a quick batch trick in there. What will happen is I will look for a directory which only exists on 64-bit systems, try and call the 32 version of PowerShell. If this directory does not exist, it's going to error out, and then draw to null, and then the regular version of PowerShell will spawn. Okay. And the next way I leveraged PowerShell is with Metasploit PSExec. So this is something I've seen done in a couple other ways, but this is what I've developed and had pretty good success with. So what a PS1exec is, it's an auxiliary module, which what it will do is you can specify number of remote hosts. Since it's an auxiliary, you can just throw it in the whole subnet if you wanted to, really. But what it will do is will do pretty much what PS1 encode does. It just uploads automatically the file, run it, and gets you a shell. Again, for pivoting around the network, this comes in handy. Again, so architecture independent and can be targeted on multiple hosts. And here's a quick screenshot of some of the options you have to set up for it. So just local host, so obviously the handler. The payload, I typically stick with reverse HTTPS. And then the other, like domain, username, and password. So, kind of to recap some of the things we talked about here. So, starting with task scheduler and BitsAdmin. From there, we'll go to our web server text page, from which will give us an interactive command prompt. At which point we don't have an interactive session yet, but if we want to, what we do, we generate that shell code, the PowerShell-based shell code with PS1 encode, paste it on there. Again, next time system phones home, we'll get an interactive Metasploit shell. And further from that point, if you want to pivot around the network, you can use PS1exec, and then again, all Windows tools that should not cause any red flags. So all these tools I talked about, the three of them, they are available on my GitHub account, so you guys are free to take them, modify them, or give me any feedback if you have. And also, here's my contact information. You can also give me feedback, email me if you have any questions about it, but that's pretty much all I got. So if there are any questions, that'd be a good time for that. No? Oh, got a question?
What's your typical method for getting the task scheduler?
The Metasploit module itself, the backdoor web, it will set up everything for you. So once you put all the options in, you specify your your local host, all the information like that, it will do everything else for you. So it will pull that information from these options and just upload on your system. You don't have to do anything. So it's all automated. Yes? Users now. Oh, you mean how to get on that system? Oh, that could be pretty much any way. So typically, this is something we use to get a persistent access, like as a post-exploitation. So typically, social engineering, phishing, after we have a session already, in case it dies, we want to make sure we can access the system again. We'll just set this up on there. Yes?
From the defense perspective, should a network admin ever actually see BitsAdmin going outside of the network if they've got internal SCCM and things like that?
Typically not. Again, BitsAdmin, even the command line utility has been deprecated, so users should not be using BitsAdmin. Again, it's a tool that's allowed just because it's just a native Windows tool. It's there, exactly. But from defense point of view, I would say the main thing you want to focus on is where you're hitting, so where your host is going out. Since I'm just hitting a random IP address, ultimately, it's going to be the filtering. So you should be doing firewall, proxying.
The proxy notice a user agent with BitsAdmin?
You could actually, yeah, it will actually show up as BitsAdmin, so that's something you could do. You can block any BitsAdmin traffic. Also, as an alternative, you can schedule tasks, set up some group policy, just kills all scheduled tasks. That could be a good defense. Yes? What is it? Yeah, you could have, PowerShell can call BitsAdmin, it's built in, but again, you would have to have the execution policy, you have to bypass some initially because those are enforced if you want to do that. So, even though it's deprecated, the command line utility, you can still use it. I tested it in 2012, it's still on there, so this should probably work for a while. Yes? That is a good question. Yeah, what I've done is the module itself, the BitsAdmin, it will do a couple things. It will actually take in users' proxy settings. So whatever the proxy settings the user has in the browser, it will take those. And when it's going out to my server, I have it configured to accept any self-signed certs, just because typically the traffic when we use it is we go over SSL, just so you can't see those directories, like where the user, domain, and in case someone's snooping on the network, they shouldn't be able to see that. So yeah, we use SSL, and it just accepts any self-signed certs. Yes. What else we got? Any other questions here? Okay. Well, thank you. Not sure why I wouldn't go full screen.